Microphone live? Right, well, welcome everyone to Foster G UK Local 2023 and to Fraser House. I'm Barry Rowlingson. I work at the university in Lancaster, and helping me chair or co-chairing is Johnny Huck over there, who works at Manchester University in the geography department. Brilliant, okay. So if I can figure out the clicker, which is next slide. That one? Yeah. Okay, so I'm going to run through these in about 5 minutes, just because we have to connect nationally at 1:45. If anyone has parked the car, I've said this several times because Rory always says this several times when there's a meeting here. If you've parked in the car park here, make sure you put your registration into the machine, otherwise you'll get a ticket. The toilets are just to the left of the kitchen. The kitchen we can use, help yourselves to tea and coffee from the machine. I've got some fruit juice and some cake, help yourselves as well on the desk. In an emergency, the fire alarm will go off and we will exit through there, or I don't know if there's an exit at the back, but just follow the people. There's a code of conduct for the meeting. It's the sort of standard OSGeo code of conduct. Just by being here, or people who are viewing online, you're agreeing to the code of conduct. And OSGeo is a very welcoming organisation, and we encourage people to attend and participate as well. So this is great that we've got people here participating. Participation also means talking to your neighbours and generally finding out what everyone's doing here. So we may have some kind of hopefully everyone will socialise and talk during the breaks, and we'll make some connections. The short version of the code of conduct is everyone is welcome, and make everyone welcome and be nice. So that's the short version. The long version goes into more details. If you have any problems with anyone's conduct at the meeting, talk to me or Johnny. If you have a problem with me or Johnny, then email the OSGeo people, and me and Johnny will never be allowed to run one of these meetings ever again, which might be a blessing, might it? Don't know. Okay. Hopefully none of you have paid for this attend here, because we have generous sponsorship from our sponsors. Fraser House has let us have the space for free and let us have free tea and coffee. And the Lancaster University Data Science Institute have funded the lunch. So big thanks to our sponsors. If you did pay for the session and you didn't get the discount code, let me know and I'll see if I can arrange something. We've got national sponsors that are sponsoring across the 8 sites. Address Cloud, who are a addressing and location services company. The British Geological Survey, who are the sort of national geology and geoscience organisation. And Aston Technology, who are represented up there by Dave. Are you an enterprise open source GIS solutions company? Brilliant. But the overall organisation for this meeting is OSGeo UK, which is the UK chapter of OSGeo. OSGeo is the Open Geospatial Foundation, which is a not-for-profit organisation that works on global adoption of open geospatial technology. OSGeo UK focuses on the UK. We want to make a focal point for developers of open source geospatial and users, doing networking, doing events like this, and to promote open source geospatial software for all types of users. So we've got all types of user, I think, represented here. So this is great. Okay, snacks for breaks are over there. Lunch will be 12:45. It's all vegetarian, and the dietary requirements that I had in the forms have been passed on, so there should be sort of special, there may be special plates for people with dietary requirements. The programme is not being changed much. The white events are local. The blue events will be national, so they'll be on screen. The beige events are local social times. The only change to the published programme is that we don't have a sponsor to talk at 2:30, so we're going to do Barry's House of Map Games. Okay, quick 15-minute quiz with a prize. I've come up with a prize. And then we wrap up at 4:30 and we're all out by 5. Okay, if you want to ask questions to any of the network talks, then there is a link to YouTube on the main page, and talks will go through on the chat box on the YouTube page. It will help if you mute and pause the streaming on YouTube so that we're not everyone trying to download a dozen YouTube streams. It might not be good for the Wi-Fi. And as ever with an event, spread the word. We've got a hashtag, Phosphagy UK 2023. Use that on across the social media. Tell your colleagues afterwards. Check out maybe the OSGeo mailing list and the UK group, and of course use open source software. So any questions about anything before we switch over to Nick, who is the national chair for the 8 sites? Okay, great. Johnny will now switch us on.
No sound coming through. No sound coming through. Should have food.
Okay, I'll try and talk through. The meeting feedback form, there will be a free draw from Locate Press. So at some point by 5th November, I don't believe, scan the code, fill in the feedback form, and chance to win one of the books from Locate Press.
Sorry?
New audio device.
Yeah. Oh, I see. Did not? Just take it through it, didn't I?
Should see it as a video.
Oh. Well, it's a different time zone.
It's 9:46. Is that in full screen ready?
That's as far as it's going to go. The YouTube seems to be.
Delete it.
Please do let us know. So, I didn't check the schedule, so I don't know how quickly we go into breaks. So I will try and be fairly efficient.
Yeah, don't worry.
I don't want to take away coffee time.
So I invited our 2 local sponsors to come and give a quick talk. And this is the first one. Nobody turned up for the second one, so we can do the quiz. And Rory Southwood. Is it pronounced Southwood? Or
Southworth, yeah. So the building you're in right now is Fraser House. It's a tech hub. You can probably hear and see it. There's 119 businesses, all tech and digital businesses that work out the space. So we've got quite a nice little community here. So I was going to talk about how many people are somewhat local to Lancaster. That's good because it's all about Lancaster. Great, cool. We were speaking earlier and you said you come from Harrogate. I was like, bugger. Thanks. Cool. So yeah, so the space we're in here, Fraser House, it's run and owned by Lancashire County Council as a economic development project in terms of trying to get businesses to collaborate, work together. And it does a pretty good job of that. Over 25% of all the businesses that you see in here, it's probably more that you won't see in here, are working together and sharing paid work. There's a lot more in terms of just support. Like I forever surprise myself when I'm walking past and there'll be like 6 different businesses all in a meeting room doing something that I'm not sure what they're working on. But we get these like spin outs, like a university, we get these spin outs of these like tech hub businesses that are doing different activity. So my thought was I was going to share all the different kind of activity that's going on in Lancaster, kind of in Lancashire, but mostly in Lancaster around that kind of tech community. What I thought would be probably most interesting. Has anyone been to a PyData before? Just Barry? Damn, they are great. So every single last Wednesday of the month, we run a data science meetup. So it's pretty relevant for the geospatial community, I'd say, geospatial data engineering stuff. There's activity on that. We have 2 speakers every single month that will be talking around a specific subject that they're an expert in. We put on pizza. It's sponsored by Relative Insight on the top floor, so it costs nothing. We put on pizza, drinks, cakes. There's beers, wines, soft drinks, everything you could want. And we tend to get about 50 to 60 people. We fill this space that you're in right now. And yeah, we listen to 2 speakers. They're normally about 20 to 30-minute talks each, but it's mostly around we all kind of have a chat and then go to the pub afterwards and have a great time. So yeah, if you're into data science, these are really good. So every single last Wednesday of the month, if anyone wants more information around these, I will be around. You can find me and we can talk. But if you just search for PyData Lancaster, every last Wednesday of the month, 6 till 8. There's a Software Lancashire meetup that kind of happens approximately twice a month. It's just everyone goes to the local pub and just chats around software type stuff. So if you are a coder, there is no language specificness. And same with PyData, there's no language specific kind of concentration. With the Software Lancashire thing, it's just a few people going to the pub, and they tend to get around 10-ish people. But yeah, any more information on that, I can let you know. And then every single Thursday lunchtime, except for today and Christmas, because we're having our thing. But normally every single Thursday lunchtime, 12:30 to 1, we have a 30-minute tech talk, and it's from members of Fraser House and friends of Fraser House, or external businesses coming in, and that is ran by Addy, who you may see around. But yeah, so there's 30-minute talks around a different tech subject every week. And normally we run them every week without fail. So if you just turn up at 12:30 till 1, we normally get 25 to 30 people attending those. Then for women in digital, we've got I didn't even put Lancaster. It should be Women in Digital, Lancaster, the Wild Network. So that happens roughly once every month, once every 2 months, depending on diet times. It's more like 1.5. We run 8 out of 12 months. It's for women that work in the digital and tech sector. We run it out of here, and we have kind of meetups, sometimes in the day, sometimes in the evenings, and it mixes up. So there's always a time that people can come to, and there's either like a speaker or an activity around that. If you want more information from that, Alice, who's just sat over there, runs it. Then there's the ElecTech cluster. So anyone that's involved in kind of hard tech stuff, we have a cluster that meets up. I don't know how regularly, and I really should have checked because Phil Lee, that just walked in, runs it. But I can find out more information on that. Is anyone in hard tech? No, cool, no need. Then if people are looking for investment, if anyone's working for companies or have projects that are looking for funding, we've got funded activity. So funded runs out here kind of roughly monthly, and we get investors over to kind of speak to businesses that are looking to raise, normally between sort of 15K up to 6 million check size. And yeah, we kind of have different activities. So I'll go through some of the events that we've got, but anyone that's looking into getting funding or works for a business that is looking to get predominantly venture capital type equity-based funding, but also debt-based funding, we've got activity here monthly. So the upcoming events of interest, there is on the 26th of September, another one of these networking founder-funder events for the funding thing. Then we've got the Pi Day to September, so that happens every month anyway. The last Wednesday of the month, which is the 27th of this month. Next month, we've got another funding event where Pretoria, one of the investment funds in Manchester, coming up to run a kind of investment readiness workshop. On the 25th of next month, we've got Pi Data again, and then another funding investment workshop with NatWest. And then on the 29th of November, we have our Women in Lancaster Digital by Pi Data event. Intertwined into there is also all the tech lunches, but I didn't make small enough font to put every single tech lunch. It's every Thursday, 12:30 to 1. And also I didn't manage to put in the Software Lancashire meetup. But if anyone's interested, come grab me. I'll be around. My email's on the bottom of the slide. If anyone would like to try out the space, I normally offer like a quite a wild deal every Pi Data. I think I said to Barry, I'd do the same. So if anyone wants a no strings attached 1 month free membership for hot desking here, I'll show you the back room if you're interested. Normally it's £125 a month. Normally I only do 1 day trials, but at Pi Data I always do a 1 month free trial because it's silly. It costs me loads, but got to do you guys some deals. So yeah, that's pretty much everything you can get out of Lancaster for free right now. If you're interested in seeing more of the space, come grab me. But I'd give you a no strings attached month free access if you are interested. Is that all right?
Yeah, that's great. Quick question. Question of the is it on? Yeah. Of the businesses that are here, how many of them do you think have a geospatial place, location kind of angle to them?
So Fuse definitely use that sort of stuff. So Fuse are the business that, so Fraser House, the downstairs bit that we're in is the co-working space. Then we've got 2 offices above, 2 offices through the corridor and over there, and 7 offices out the back door, which you probably would have never seen because unless you go past the toilets, you won't see it. Up the stairs, we've got another 7 offices, then another 4 offices in the back. One of the offices over there, we've got a business that does the back-end software for electric charge points. They're doing some sort of stuff with it. Got to admit, I don't know too much the difference between when they're just using like image processing and when it's specifically geospatial data engineering. But they definitely have done some interesting stuff with flight paths. And then we do have a business, again, I'm never sure how much I can talk about people's businesses that does stuff in the renewable energy sector. And then everything past that, I feel like I'm not meant to talk about. There was also another business that does something similar that no longer here, but there is a few and far between. I mean, it is quite a niche subject in Lancaster, it feels, but I'd love to have more. Any questions? No questions? Any more questions? No. If you want to have a look at the space, which you don't need to, but if you do, just grab me. I'll be around. Thanks.
If you sit on your lanyard.
Oh, sorry.
Can I sit down for this? I'm not. Well, I did prompt really, so. What's the best way of doing this? This isn't a great start. Right. What's the best way of just? Is that going to work?
Bottom button. On the ring.
headphones? Okay. So just up and down, even if I need to.
Okay, so first local talk is from Tom Nichols, who's a colleague of mine at Lancaster working on this geodata science project. Tom?
Okay, right. Can you hear me? So I'm Tom Nichols, and despite working at Lancaster University for 4 years, I joined this project as a research software engineer at the end of April. So I put all the words I possibly could in this title, so I'm going to go through what all this means. But as a brief introduction, I'm a generalist software developer, having worked in all sorts of fields in industry and academia. So while I have some experience of working with geospatial data in the form of writing QGIS plugins to manipulate vector and raster data in the past, I'm by no means a geospatial expert. In fact, this talk isn't really about the geospatial components of our project per se, but more how to scale up long-running geospatial calculations and make them available on the web. So I'm going to gloss briefly over the science because it's not really my area. And I'm going to talk about the technical problem that we face. I'm going to talk about a proposed architecture that we have, that we're working towards, and the current prototype that we have and where we are now as we progress towards that. So let me just, this is my work, so I'm going to talk very briefly about this, but I'm working in the CHICAS group, which is the Centre for Health Informatics, Computing and Statistics at the university, as part of a WHO task force project, which aims to eliminate a particular set of what are called neglected tropical diseases from developing countries. In order to eliminate a disease, first you have to sample the prevalence of the disease in the population, and then you need to treat it. So the statisticians in our team, I can never say that word, have developed innovative ways to cut down the cost of sampling and providing treatment plans based on geospatial prevalence and population data. So typically, these are long-running calculations that can take up to several hours to complete. And our aim is to make these calculations available to public health workers in developing countries via a web application. So it wouldn't be a geospatial conference if I didn't show a map, but this is kind of sampled prevalence of one of these diseases and how a model predicts real distribution of the disease over the full area. Any questions? Probably you know more about this than I do, potentially. But it turns out you can design a much more efficient and therefore cheaper sampling strategy by making a prediction about where this disease will be after treatment. And that's going to be more effective and a more efficient and simple random sampling. And so that's what the project is all about. But glossing over that. So the original analysis scripts are available as a set of geospatial calculations written in the R programming language that typically provide or produce a map as output. And each disease has its own set of scripts depending on the statistical covariates. These have initially been built into Shiny apps, which is a way of adding a UI layer to an R script and making it available on the web. So what we see as an example here, we make a request using a series of data files. So we might have the prevalence, locations of possible treatment centers, covariates like temperature, humidity, and county boundaries, for example, in the form of a geopackage. So the user would upload those either in one request or a series of requests. And in response, we receive an output file back for example, in the form of a leaflet map in HTML. So the technical problem is basically that while it's quite possible to deploy a typical Shiny application at scale, the long-running nature of these scripts means that we've had to consider an alternative approach. And furthermore, we aim to be able to run a number of different analysis scripts asynchronously. So we'll need a user-friendly web application and a way to send notifications to the user when tasks are completed, or perhaps validation fails on the data provided. So our solution, I'd be delighted if people could give me feedback on this, is to use a message broker. So a message broker architecture to fully decouple the web application from the analysis task scripts. And this can help us avoid tying up the web application with long waits for results. So, so you see on the left-hand side, browser making a request to the web application, simplified here. The web application passes a request to run a task to the task producer somewhere on the network, and this is then passed to an available task worker somewhere else, and that will then run the R script until that's finished, and then notify the task producer later to send an email to the user by the browser. So according to IBM, a message broker is software that enables application systems and services to communicate with each other and exchange information. And according to VMware, the asynchronous messaging allows producers and consumers to send and receive messages independently and at different times without blocking, and that's key. So I've used message brokers in financial routing software where high volume and low latency is the biggest problem. But we can also use it in the context of asynchronous processing and task queuing. The important thing for us is that this allows our processes to talk to each other even when one of them goes down or is blocked with another long-running process. And it provides one or more message queues and a system of acknowledgements and replies that provide secure and loss-free communication. So skip over that slide. So the idea, of course, is that we can scale up the system to have as many of these analysis containers as is required and as is practical, because these will be long-running tasks. So we'll need a lot of these running at the same time. We can configure the message broker to automatically balance load on the analysis end between these worker processes. So this is our full proposed architecture. We're using the Python Django framework for rapid development of the user interface. And this interfaces with the message broker via the Python salary library. And the database will be used for project configuration, user authentication, history sessions, etc. It's a standard Django component. And we'll also need a cloud file storage area, like S3, Amazon S3 style, for storing uploaded results and to pass data around, because it's not an efficient use of a message broker. So our task producer sends out a task request on a particular queue. So we'll have a different queue for each different analysis script that we want to run. And when a task worker becomes available, it picks up the task and runs it. When it's finished, it sends back an acknowledgement and any results, and is then free to pick up a new task. And an email is then sent to the user as a status update and to allow the user to log back in and view the results. So where we are now, this is what we've built so far, more or less. All processes are running within separate, here we go. That's our current prototype. So all processes are running within separate Docker containers. I'm sorry for the small font there, but basically the gray boxes are separate containers at the moment. But they're all running within a single Docker instance on the same server at the moment, which means that we can cheat and pass data around using a shared Docker volume. But this allows us just to test out the message broker architecture and make sure it's kind of doing what we need it to do. And then we'll gradually approach the full prototype, the full architecture as we progress. So I should talk a little bit about open sourcing this project, which is our ultimate aim, although that's not in the current kind of set of milestones from our funders. So our ultimate aim is to make this open source, but there are a number of obstacles in our way. We'd like to make this applicable to any sort of analysis script. So in order to do this, we'd need complete decoupling, where we need to specify the interface between the web application and the analysis using configuration, probably, rather than code. And we need a way to specify not only the types of parameters that will be passed in the form of data files, but also exactly how to validate those files. And I just want to throw this over to you, really. What I'm wondering is, have you seen this done before? Because obviously we don't want to reinvent the wheel. And do you know of off-the-shelf open source solution that we can make use of to cut down on development time and resource? And also I'd be delighted to answer any questions that you might have. So that's it from me.
Any questions? We've got a mic.
So we do something similar at Manchester, but to load data into our cluster computing facilities. So obviously you wouldn't then have the web interface, so it wouldn't replace that. But one of the interesting things we had to deal with at the time was how are you splitting up your data? So are you dividing up your data spatially, or are you just separating separate analysis tasks into the different workers?
Well, I mean, the scripts themselves are based on the disease.
Mm-hmm.
So it's a different script at the moment for each disease, I believe.
So each work is one disease rather than a region, if you will.
Yeah, that's how we're working at the moment. At the moment, we're kind of working on a timeline for one, possibly two of these diseases.
Yeah.
Just to get that up and running and into the world as quickly as we possibly can.
Great.
And so we'll have a different message broker task queue for each disease, effectively.
Right.
But I'd be interested to know how you solved that and whether there's like anything we can use there.
Yeah, absolutely. We'll have a chat about that. Any more questions? Tom? Anyone seen anything like this before?
I'd love it if you did. I'd probably put me out of a job, but it would be good to not reinvent the wheel.
I think it's a common pattern to do this kind of thing. You often go to a website maybe that's doing satellite imagery, and you say, I want this rectangle here, and it goes away and says, I'll give you a link in 5 minutes when I've extracted it from the raw data and processed it and everything. So the pattern exists, and you're using only open source tools for what you've developed. And I think that is the nature of the beast. You jigsaw something together, you won't find a built-in thing that will implement the exact pattern you need. So, yeah, I think you've done the right thing in those. I think you've done the right thing.
Well, that's good to know.
Yeah.
Thank you.
Yeah, and I guess one thought there is that you mentioned that you're bringing together, you've got your JavaScript front end, you've got your Django, and you've got your R as well. And I would imagine that, as I was just saying, that you won't find a much more integrated solution for such disparate components. So, yeah, again, it looks like a lot of precedent. And actually, my talk next, maybe you'll see that what I am talking about looks quite similar some processing goes on in the background, more or less. But yeah, seems sensible.
Great, thank you.
Okay, any more? Right, okay, we will stick to time. So, Daniel.
Yeah. Yes, possibly. So part of, I think a challenge there would be, so it's a 4x4 kilometer field of view, so it's not wide swaths, and
No.
we basically intend to book up every imaging slot we can for different customers. So revisiting sort of daily or something like that, unless you're paying us a lot of money, booking one imaging slot a day
Yeah.
might be a little challenging. But yeah, we do have some ideas of, so actually we don't just get a single image, we actually get a set of at least 25 frames. And my satellite, because it's whipping along at 2 kilometers a second, there is some visible motion there. And there's ideas of, could we maybe actually just detect the clouds from them moving slightly? Sadly, no satellite images or videos I could show here, but yeah, there is certainly one case where I think we had everyone was staring at an image going, what is this weird, slightly dark patch? And like the whole team for a day. And then we viewed a little video and they went, oh, it's a cloud. It was obviously just a cloud moving over, but yeah, it's
Okay.
fun problems. But yeah, happy to
Thank you.
talk.
Question? Very quickly.
Thank you. Yeah, I enjoyed the presentation. Thank you very much. I'm interested, I guess, about the time from when the image is taken to when it's available for use. So could you use it for applications like identifying some of the forest fires and stuff, or would it take too long?
So we are going for as short as possible. So for actually processing an image, I think we're on the order of 15, 20 minutes once it comes in, and some of that's big, chunky machine learning, getting points. The bigger limitation is actually really a satellite going over a ground station to downlink the image. But that's life. But yeah, we're hoping within hours at least. But yeah, happy to talk about stuff like forest fires and all that.
Thank you, Daniel. Right. For me. I'm on next. Yeah. Before Daniel goes, our speakers are getting complimentary T-shirts. So I forgot to give Tom his, but
Thank you very much.
Daniel's a large and Tom is an XX large. Although I shouldn't tell people what size they are. That's probably confidential, sensitive information or something. Okay. This is a fun talk. Oh, can you pass that to Johnny? Right, this is a fun talk. Not that the others weren't fun, but this is nothing to do with my work. It's purely something I did during lockdown and beyond to keep me entertained and stop me losing my mind. And it centres around this fine fellow, Group Captain Peter Townsend, born in Rangoon, 1914. It's not Rangoon anymore. We'll come to that, perhaps. He died in Saint-Léger-en-Yvelines in 1995. In 1930, he joined the RAF as a fighter pilot. By 1944, after serving in the war, he was equerry, so assistant to King George VI. And in 1952, he was comptroller to Her Majesty the Queen Mother. So basically running the shop for the Queen Mother. Now, you may have heard of this chap if you watch The Crown, because he had this romance with Princess Margaret. And it lasted for a few years. And because he was already divorced, and that was scandalous, he was told that he couldn't marry Princess Margaret and he had to end the romance, and that made the newspapers. And I kind of realized that the more publicly a man gets dumped, the more extreme his reaction. So Peter Townsend's reaction to being publicly dumped in the newspapers like this was to drive around the world, because, who wouldn't, right? What are you going to do? So he drove around the world and he wrote this book about it called Earth, My Friend, published in the late 50s. And this is one of the maps from the book, this fantastic old style cartography. And you can see his route across Europe, Asia, Australia. He did a few side trips and a bit of exploring and on foot, and shipped the car across, and he had to get the car on a train and stuff. Fantastic book, very much of its time. And the pictures in the book are black and white, fantastic things. You worry about potholes on your street, they had to build the road, okay? So he's building the road. And this was North America, the glaciers and the mountains. This was someone carrying a coffin down the street for some reason. And this was his car. It was a very brand new, they look old now, but this was a brand new 1950s Land Rover Series 1. And one of the things I did was to take some of his pictures and go, I wonder where exactly that was. And go into Google Earth and Google Street View now, and you can pretty much locate exactly where these pictures are. This is coming over sort of Cumberland Gap in North America, looking down into these lakes. This is the Great Divide across the continent. That was the road then. The road now is now an 8-lane highway just off screen here. So it's not on Street View, but some tourists have taken pictures of the old sign. You find that on Google Maps, and you can see the changes. I mean, it's fascinating stuff. And so I'm sitting around at rereading this over lockdown, and in November, someone online, I've forgotten his name, runs this 30-day map challenge. So 30 days in November, every day, make a map. There's a theme. So day one might be red. So you make a map using red for some reason. It might be a map of vampires, and you map it with blood or something. Day 2, green. Day 3, blue. Day 24 is 3D or something. And people will create maps and tweet them or X them, whatever. He's figuring out what social media to use for this year, I think. And I thought, okay, day 30, I've made 30 maps, managed to do it. Day 30 is kind of free. Make a nice map. So I thought I'll just kind of trace out the rough route of Peter Townsend's trip, and I'll put it in a little map layout and add the book and do a bit of cartography and make it look nice. And you can search for the 30-day map challenge and see what happens with all this. So that was all very nice. And I kind of thought, well, let's expand this. Let's find all the places he mentions in the book. Let's take the name that he gives it in the book and the name I find on the map, the day he gets there, the day he leaves, the page number on the book. Let's kind of book map this book. So I opened up a new QGIS project and off I went, rereading from page 1. Page 30 I get to. This is the first location. It was on Sunday, the 21st of October, when I drove out of Bruxelles. Okay, easy one, right? It's just Brussels. So in we go, first entry in the database, Brussels, 21st of October. Brilliant, this is going to be a piece of cake. I'm just going to reread this book and I'm just going to fill this database and I'm going to have all these locations. Page 31, next page, easy peasy. He's in Germany, what could go wrong? I joined the Autobahn and settled down to a sedate 45 miles an hour. That's top speed in a 1950s Land Rover, okay? Mannheim, Stuttgart, and Mulhausen fell behind. Mannheim, Stuttgart, and Mulhausen. Okay, let's find Mulhausen. So you search for it in Google Maps, and you've got Mulhouse in France, Mulhausen in France. It can't be those. You've got Mulhausen im Tal, excuse my pronunciation, Mulhausen, Grefrath, and Mulhausen. Okay. This is German for Millhouse. And so there's going to be a lot of Millhouse places in Europe. So obviously context helps. So I fire up OpenStreetMap. I know he's just left Stuttgart. I know that the next place I've found is Ulm. So I scan down here and I found a place called Multhausen im Taller, which Wikipedia tells me it changed its name. Brilliant, got it. So name changes were a big problem to locating a lot of this. And this one stumped me for about 2 years before I decided the solution. He's in India or in the Indian subcontinent somewhere. The mountains of the Khyber lay far behind, so he's come over from Afghanistan. And the road ran on through Rawalpindi, Jalandhar, and Gujarat. The shades of Kipling and the Indian army still hover about these garrison towns. Lahore was my destination. At Amritsar, I left Pakistan. So he's going through Pakistan. Just after partition and all that. So Rawalpindi, Jalandhar, and Gujarat. You look on a map, Rawalpindi is up here, Gujarat is there. And then he talks about Lahore and Amritsar and leaving Pakistan. And I spent ages looking for somewhere called Jalandhar between Rawalpindi and Gujarat, because that's how he expresses it. The only thing I could find that was near was Jalandhar down here, further south. And I wasn't sure. Why is he doing it in that order? Why does he say Rawalpindi, Jalandhar, Gujarat? Is he just talking about the towns in general for some reason? I ended up finding a 1940s a gazetteer of place names of the British Empire and couldn't find a Jullundur up there. But eventually, and I say it's taken me a lot of soul searching to decide, I think he was just mentioning the town names for some reason. And I found the Connaught Rangers regimental history, which says in the Indian city of Jullundur, now Jalandhar. So I'm pretty sure that's where it was. So yeah, new names for old. Some of them are fairly familiar. He talks about Peking. We know that as Beijing. A lot of places in Africa and the other former colonies have changed. So he talks about Fort Jameson. If you look up that in Wikipedia, it takes you straight to Jakarta and tells you Fort Jameson was the name. And places like Leopoldville is now Kinshasa, and so on. So you kind of learn that there are ways of finding old names for new places. And geonames.org is a really nice open database of place names that you can search. So he's going through El Golea, couldn't find it in Google, couldn't find it in other sources. I stuck it into geonames, and it gives me the first record is El Menia, and then El Golea Airport. They're in Algeria, which is roughly where he was, so I know I'm kind of on the right track. Brilliant. The reason GeoNames found it is because it keeps a record of alternate names for a place. So it's got El Golea and El Menia in its database, so it keeps historical place names. And once you know it's now El Menia, you could look that up in Wikipedia, tells you the former name is El Golea. Brilliant, stick that in the database. So I'm working through all this. A lot of the base map layers that we have got place names in, and they're really helpful. So he talks about Higesawa. Over the hill from Kaida is a hamlet called Higesawa. You can walk there through a wood of silver birch saplings. Now, I'd already found Kaida. It's down here in the Valley Road here. And he says you can walk there over the hill. And just looking at the topology, it seemed to be this region. It seemed to be up here somewhere, I think. And the only thing on Google Maps is Higesugu. And we're looking for Higesawa. Maybe it's the same, not sure. So I tried OpenStreetMap. Now, OpenStreetMap, I now realize, does everything in the local language of the place you're in. So it told me that that river was called this. And I remember from my visit to Japan, this is the symbol for river. It's the water flowing between the banks. So I found the river, but I still didn't know what it was. And then I discovered osmap.uk, which has all the English labels for everything. And the river is labeled Higesawa Kawa. And Kawa is river. So I found the place. If I looked on Bing or Esri maps, it gives me Higesawa straight away. So I was getting used to looking through several base maps for each location. My QGIS project now had about 8 different base maps that I would have to toggle through looking for places and zooming in. There are some fantastic online map libraries. This is the Peri Castañeda library hosted at the University of Texas. And the detail of some of these maps and the span of them is quite incredible. Covers the entire globe. And most of them seem to be American military declassified maps. So this is an area of, I know, Bolivia or somewhere. Yes, Bolivia. Bolivia, Chile, Peru border area. And the detail on these things is, you can zoom into the individual farms, contours, the details in the contours. They must have got these from the national mapping agencies and then produced American maps over them, because I don't think the Americans were actually surveying South America in such detail. But this helped me out on several occasions for some of the more obscure locations that he was driving through. I mean, I say the Americans weren't surveying this. Then you run upon a map of Vietnam in 1970, and you see things like destroyed, 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 and then you realize, why are the Americans mapping this? Well, it's power. Maps are power, and maps are political. Yeah. I also kind of dug into a few more different archive sources. This particular day, he's in Canada. I slept that night in the car in a camping site on the banks of the Rocky River. There was one other occupant. In fact, he may have been the owner, an excessively inquisitive squirrel. He stole some of my supper and shinned up a tree and swore at me. He didn't like that squirrel. Anyway, campsite on the bank of the Rocky River. I know he's just come through Jasper. I find this map on the Internet Archive, which is a fantastic store, not just of all the web pages that they archive for history, but they've also scanned thousands of books and maps and old videos and audio pieces like old 78 records, obscure bits of ephemera, old software. They've got things like, if you're kind of designing any graphics or something, that you'll find 1920s carpet company pattern books, right? They're all in there. This is a map of Alberta highways. So there's Jasper, there's the Rocky River, and the Rocky River was hard to find on Google. I couldn't actually find it. But eventually, there's also the David Rumsey map collection, which is another historical map collection. You can search by date and location. And again, found the Rocky River, no sign of a campsite. There's a hot springs on there. This was 1956. He didn't mention hot springs in the book, so maybe it's not there. I also found University of Calgary has a nice archive of maps as well. And there I found, coming out of Jasper, on the Rocky River, a green triangle. Look on the legend, green triangle is a campsite. Bash. That's where he was. Somewhere in North America, I crossed the turbid stream, the Pea River, and came to a place where in 1837, the last Indian battle in Alabama took place. Here, General Wellborn and his men attacked and routed 300 Indians. So there's an example of the language of the time. We wouldn't call them Indians now. Okay, so the Pea River. Looking at locations either side of that text, he's somewhere between Eufaula and Greenville, and there's the Pea River, and there's half a dozen places that he could cross. So I do a little Googling. Where were the last battle in Alabama? And you find a page like this describing the Battle of Hobbs Bridge. And from there, you can find out where that happened. And from there, I can put it on the map and can be fairly confident he crossed the river at that point. So I'm getting into all sorts of history, both on a big scale and a small scale while I'm doing this work. And I really kind of got into it and got interested in it. And this was my favorite ever. This was just, tell me if I got too obsessed with this, right? I crossed into Manitoba and stopped at a little petrol station. Opposite, a log cabin stood in a shady grove. The proprietor, Jim Coots, invited me to spend the night there. I cooked a meal and settled down for the night under a mosquito attack. So that's all I've got. Jim Coots, log cabin, border of Manitoba. I know that he's between Yorktown and Wasagang, and this is the border. And the two main crossing points, because there's a river running up here, are here near Roblin and here near Russell. So what was it, the northern route or the southern route? You look at the northern route, he comes across the border, then hits this lake and then carries on. You look at the southern route, he crosses the border and goes into this sort of woody, damp-looking, marshy, mosquito-infested area. And he said he got eaten by mosquitoes. Okay, so maybe he took the southern route. I pull up some 1950s maps, and that lake isn't there. Okay, I dig a bit more. Turns out that lake was a reservoir created much later. So I'm back to square one. Did he go north or south? And at this point, I kind of got stuck. I looked at these 1950s maps of Manitoba, which have these fantastic covers, this gorgeous art for the period. They're online. That's one of these maps on the left. If you ever want to drive around Manitoba in the 1950s, they've got them back to the 1920s and forward to the 2000s. They're just beautiful, beautiful map objects. Anyway, I'd given up. So I asked a Canadian friend of mine, have you got access to the Canadian census from the 1950s? I'm looking for Jim Coots in Manitoba. I thought I'd throw that out there to Patrick. And because he's Canadian, he's really friendly, so he's going to do something, right? He emailed me back the next day. He found the tribute page to Olivine Coutts, who married Jim Coutts. Mum and Dad moved to Valley View, 8 miles west of Roblin. They purchased a country store, service station, and 3 log cabins. So 8 miles west of Roblin is that northern route. I'm getting somewhere. The next day, Patrick says, oh, I've got this. So I've got Jim Coutts' grave on Find a Grave and Olivine's grave, although she died in 2020 at the age of 101. Jim, we see, died in 93, age 78. So then Olivine lived another 30 years without him. So you start to draw a picture of these people's lives, but we still don't quite know enough about the location. The next day, Patrick got back to me again. I found this. This was at the University of Manitoba Libraries, the Shell River Municipality, Century 1, 84 to 84, Memories of Roblin and Rural Districts, okay, in a sort of green leatherette cover, scanned at the University of Manitoba. And this is a sort of micro-history of these 100 years, describing all the families, all the work that went on, all the building, and there's a picture of the cabins. So, or at least a picture in 1959 of the Valley View cabins. To dig that up from just 2 words in this book from 1955, we think that today everything is being scanned and digitized, but they were doing it in the 50s, up to the 1980s of everything from 100 years. And the detail in this book, this is like 600 pages, this first volume. I can just read this for the stories sometimes. During the exciting afternoon of events, this is celebrating the new road, a tragedy occurred. A Mountie shot a woman who was at the picnic. She later died. She was from California. That's the level. I want to know, why did the Mountie shoot this woman? Why was she there from California? It's just, and maybe I'm getting too obsessive when I start thinking I should now try and find out who this woman was. I look at death records from Roblin in 1930. Okay, I'm getting far too obsessed. Anyway, as I was finding each location, I was saving a geopackage, and I was creating an online map through GitLab. And so I could build every night when I hit a button, I could build a progress map to show how far I'd got with mapping this book. And this was at the very end when I'd got all the way around. I had a total of 514 locations in my QGIS project with the name that I found, any arrival days and other information. And you can plot all those points on a map, and they look like that. So I wanted to do some nice cartography. The first thing I wanted to do in QGIS was to turn those points into lines. So I kind of categorized them into sections. So I've got another column in my database for the sort of section, and I'll put a sequence number in as well so I can plot them in order. And you can then create a virtual layer in QGIS, which makes a line from the point layer, just selecting one of these regions, sections in that order. And that gives you some virtual layers that will then map as lines in each section, which is nice. So that's his Asian overland section. I did that previous map using a sort of overhead view of a Land Rover that uses QGIS's styling tools so that it can rotate. So this little Land Rover kind of drives around like that, which looks quite nice. And I did a lot of playing with the cartography. I made a side view Land Rover icon, but in QGIS, it looks fine when it's going one way, but it turns upside down when it comes around. And I've got an open question on Stack Overflow trying to figure out how to fix that. The old maps in the book have this sort of coastline effect, which I've duplicated a bit in QGIS with some line overlays. I've seen other people use buffers and geometry generators for that, all very nice. Another thing I wanted to do was to try and present more on a page using this sort of strip map style. This is a road map of York to Lancaster, where everything is kind of chopped into straight lines. This is from 1800 or something, when Lancaster was there. We are about here somewhere now. And you can do that in QGIS through the map composer. You can sort of chop it into sections, something I might explore later with the cartography. I don't know what to do next, okay? every year, the GeoHipster people produce the GeoHipster calendar, and I'll probably try and do a much nicer version of some of these maps for the GeoHipster calendar this year. I had a map in the GeoHipster calendar a couple of years ago. I did a map of not Island, Sans-Serif. I can tell you about, maybe I'll do another talk on Sans-Serif. I might do a full 12-page calendar for my friends this Christmas. I might just do a big poster for my wall or something, and if I'm lucky, I might get a 12-part BBC 4 TV series. I kind of joke about that, but then I realized that a lot of what Group Captain Peter Townsend did was covering the same ground that the first overland team did in 1955. This was an Oxford-Cambridge expedition from London to Singapore. In 1955, there's another great, I've got this book, it's great. And then they kind of did the return trip, or someone else did the return trip with one of the guys from the first trip in 2019. Ooh, that's food. So he did the return trip in 2019, and I could go back to my first overland copy and try mapping that, but they've mapped it in amazing details. And obviously they had to change the route in 2019. So you've got the old route and the new route there, mapped in exquisite detail. And if I want to do another mapping of a book, well, I'm kind of tempted to do this, right? This is a guy who in 1896 jumped on a penny farthing in San Francisco and drove and pedaled around the world, okay? The first 600 pages gets him to Tehran. And I've had a quick look through, and there are so many place names. It would just be, I don't know, take the rest of my life to try and geolocate all of this. So that might be my next project. Although my next real project should be to get my Land Rover working again, because the clutch has failed shortly after I had it restored to lovely, shiny detail at great expense. So yeah, that was around the world using open source and open sources. If anyone has any questions about anything in there, just come and talk to me at lunch, which will be now. This is lunch, well, not Maxine herself. Yep. Great, there is absolutely plenty. So if anyone from Fraser House wants to tuck in that one. Yeah, thank you. Normally I'm modeling diseases, and I'll talk about that later. Pardon?
Do we need the mic to comment or ask for it? Maybe you have yours. That's fine.
Very nice to meet you.
Okay, Max, thank you.
Thanks, Barry. Thanks so much, Barry, for this very interesting talk. I'm particularly interested in that because it's drawn from text. So currently we are working on the Lake District writings from 16th century down to somewhere in 19th century, and how people describe their, tourist activities around the Lake District. So this is quite handy. My question is, so I get to understand that you're looking for toponyms, names of places, and that helps you decide which chunk of the text you will pay attention to, right?
Mm-hmm.
So, okay. So to be able to find, because sometimes you have to think about some of the geographical features mentioned around the place, like the lake or the bridge or whatever, to be able to finally find it out. So how far do you go? Is it your head saying, okay, I need to take this chunk of text with all that I mentioned there? Because I'm thinking of how to do that with NLP, some automatic means of processing the text.
Good luck.
How do you chunk it? It's in paragraphs, in sentences, and all that.
I think you've got to be flexible. I think you have to kind of look, and sometimes it's easy, and sometimes, like with Julandur, it was in completely the wrong place in the text.
Yeah.
That really threw me, and for a long time in the database was don't know.
Yeah, because you usually don't write, in that chronological
Yeah.
order.
Yeah.
Okay. Thank you. The other thing is, can we have that slides or list of all these resources that you mentioned?
Yeah. Yeah.
Thank you.
We'll do. I'll get that round.
Thank you.
Not really sure. I'm just going to hold this. Great.
That's
Yeah, do you think it'll work?
what, yeah, it is quite good. Squeeze it in.
Oh, thank you.
Yeah,
Thanks.
got that.
Perfect. Okay, great. Thank you. Hi, everyone. Thank you. I'm Katie, not Catherine. It's September, not October, I think. I just moved over the weekend, so I'm a little confused about where I am and when it is. I'm going to be talking about a piece of software called MapReader, which was developed in a project called Living with Machines, which I've been a part of with a number of people at the Alan Turing Institute in London for the last 4.5 years. Living with Machines, I'm going to give you a bit of an overview of kind of the big project, and then I'll dive into MapReader. So Living with Machines worked with a bunch of the materials, as you've just seen, like maps that have been digitized from the long 19th century. This is just British history, so no, not the whole world. We used computational methods from multiple disciplines to analyze these digitized collections, which included maps. So we worked with the digitized Ordnance Survey collection that is at the National Library of Scotland, which has the largest digital collection, whereas the largest physical collection is at the British Library, but sadly, mostly not scanned. We also worked with newspaper data, census data, books, all kinds of other information. This is really just a part of the team. I would say about 40 people worked on the project over the course of our whole time span. Ruth Honor, who was our PI, is here, and the rest of our colleagues. One person who's not on here, I do want to mention, is really crucial to the MapReader development, was a software engineer, Kazra Husseini, who was at the Turing for most of the project. So why maps for Living with Machines? On Living with Machines, we were interested in understanding the impact of industrialization on people's lives in the 19th century. And maps are a really interesting place to actually look at the kind of physical imprint, right? The footprint of industry in British communities. And Ordnance Survey maps, the 25-inch, the 6-inch maps that were created from the mid-19th century onwards, have incredible detail, as you can see here: gasworks, mills, engine works, obviously the railways present on these maps, and they cover the entire nation. So you might have heard, right, that the UK, as an American, this is really hard for me to digest, the UK is the most mapped country in the world. And we were excited to work with the first products of OS mapping, really. And a huge shout out to the NLS and map curator Chris Fleet, who made it possible to work with these for our research. Okay, right. So typically, when I'm a historian, so I'm going to talk a lot about like how historians or other humanities or kind of qualitative social scientists might normally have approached working with maps. And then how we're trying to think differently about working with maps. So this is the reading room, the maps reading room at the British Library. And a lot of the way that we work with maps is kind of structured by this physical space. The tables are a certain size. The map librarians can only bring out a certain number of maps at a time because of the size of the carts and the number of readers they have to cater to during a day, or the preservation status of an item. And so we're very used to spending a lot of time looking at, thinking with, writing about very few maps, one map at a time, a few maps at a time. And so scholarship that has engaged with maps as what we call primary sources works with maps kind of at that scale. However, now that these maps have been scanned, there's a real opportunity to think about working with the whole collection, right? All of the maps that were printed by the OS in the 19th century for the whole nation. And that's really just not something that's, this reader is not going to sit and look at every sheet. For the 25-inch sheets, that's 50,000 sheets per edition. I don't want to think about how much time that would take. And what are you looking for on there, right? So it's not something that you can do manually. But we haven't had methods for approaching maps at scale for humanities research. And that's really the task that we set ourselves to. So we were working primarily with the 6-inch to the mile second edition maps, which were printed from the sort of 1888 to just before the First World War. This is about 15,000 sheets for England, Wales, and Scotland. All right, so we're excited about trying to figure out how to make trustworthy historical claims based on lots of maps. So take this kind of critical reading that we're used to doing in the humanities, apply it at scale. In the humanities and social sciences, we kind of have two ways of engaging with data. And this is, really boiled down, obviously. One approach, and this is kind of what I'm trained most in, is, okay, we're going to go into the archives. We've just seen a nice example of this. We're going to go into the archives. We're going to look at really high resolution information for very few places, right? And that is going to be our evidence base for our article or our book project. The other thing that we might do is, if we want to look at something at scale, we're going to have to aggregate that information. And so people who work with the census are used to doing that. They don't work with, looking at every single person in microcensus data. They look at census data that's been aggregated at the parish level or the county level. And then they can make claims based on arguments and information that has been aggregated. So these are the two, if we think of these as two extremes, we were interested in the content of these maps being very high resolution and yet national at scale. So we can really think about how to move between these different approaches to research with maps as our sources. All right, so we wanted to do this in a way that actually also challenged some of the traditions for working with GIS in the humanities. So historical OS maps really tell us how Victorians represented their landscape and how that landscape was changing, but they aren't actually a ground truth, right? They're not, photographs also aren't a ground truth, but they're even farther away from that. We cannot ground truth the past. So we need to really think about how are we structuring the data, how are we using computer vision and machine learning to create information that is trustworthy from a kind of historical perspective and isn't just taking the maps a bit too much at their word, right? We wanted to really think about not defining truth, but advancing interpretation. And finally, of course, there's simply too many maps to do this all by hand. If we were to open up QGIS and start drawing all of these features, it would have taken us years and years and years and years. And if we had changed our mind along the way about what we wanted to capture, well, we've all been there. So the idea was to make it possible for people who are not massively skilled in computer vision and machine learning to work with these tools, to work at scale with big collections of maps, and to do so iteratively, right? To really be able to think with the map collection as a set of objects that they can learn about the past, tweak their questions as they're going without the kind of cost, right, that would incur if you were doing this in a kind of manual GIS setup. All right, and coming up to a kind of theoretical critical data studies approach, one of the things that also was motivating us was this idea of moving away from the idea of we're just mining maps for information. We're just going to extract. We're going to treat these maps in a kind of exploitative manner. And this was something that was really important to me as I've been working with a lot of computer vision scientists who are doing a lot of work, have contracts with DARPA and are, kind of industry focused. And I'm keen to hear your thoughts about this because I'm really interested in this idea of doing something differently, designing methods that allow us to think differently with maps so that we're not mining them, right? We're learning from them and we're understanding them and we're interpreting them, but we're not mining them for some kind of correct information, which will then link out to other information and make claims about. All right. So the idea is that we want to create a kind of new cultural spatial data. We want to be able to identify and search for new shapes that are intentionally imprecise visual signs that form new patterns rather than reproducing the traditions of manual vector data collection. Now, what you see here on the left is a really fantastic data set created by a group at Cambridge that basically they're historical demographers and geographers. So this is historical railways in Britain. This data set exists. It's based on a compilation of information from archival sources created by someone who sort of did this in his spare time, and then they gave him an honorary PhD after having completed this work. So this is a really important data set that we have, but it captures something very, very, very specific about railways. It captures only the tracks. It doesn't actually represent railways as they are on maps. If you overlay this on the OS sheets, you see that there's lots of information missing. So this is one of the things, and it took him about 10 years to do this. So we wanted to think differently about data. So our solution is that we're going to work with something which is very common in CV world. We're going to take what it's called the parent image. This is the whole map sheet. We're going to divide it into cells or regions, which we call patches. And these patches become our unit of analysis. So the patch is what we are actually running through a machine learning pipeline. We're just doing something really simple. We're just doing an image classification of the patch, right? So we come up with a set of labels and we ask, is this label, ABC, contained within the patch? That's how we go along. We're not doing any kind of segmentation, object detection, anything like that. So the idea was fast, efficient, easy, user-driven labels. And we were really excited about this idea of patches as a kind of new kind of humanistic data for maps. The patch is something, that there's already a lot of technology that allows us to work with the maps in this way. And historians we thought this would work really well for historians because we weren't asking them to really think massively differently about the content. We were asking them to look at an image and interpret it using the kind of toolkit that they might have for looking at a single map. So the kind of, at a philosophical level, this was really interesting to us. So of course, you can't choose a label that has no relevance, no connection to the visual signal on the map. So you can't say, for this map, I want to know, was it smelly? Right? Okay. The CV model isn't going to find that. Right. So there is this kind of back and forth between understanding the thing that you want to find out, right? What you're trying to figure out, what you want to learn about, what is machine readable, and therefore what labels you need to choose for your project. So this is something that this is an iterative process. It's intentionally iterative. We don't expect people to get it right the first time. It's set up to be iterative. And it helps you really think with the material as you're going. So just as a quick example, the patch size is also variable. So you want to think about the patch size and the labels, right? So if you are looking at a patch that's 1,000 pixels by 1,000 pixels, you can also define it by meters. This is too big. There's too much information here. If you have a 200 pixel wide patch, you can identify forests or woods. But if you want to identify only trees, you got to go smaller. All right. So what did we do with this so far? We have, as I hinted with the railway data set earlier, we've been trying to think about the presence of railway infrastructure in a different way. And so instead of capturing just where were the tracks and kind of having an economic history or transport history hat on, we've been trying to think about, the kind of footprint, the kind of totality of infrastructure, rail infrastructure in the British landscape, which we call this new concept that we call rail space. So effectively, we've predicted the presence of rail space using MapReader on these second edition OS maps. So here, these are the outline of the map sheets. This is the predicted rail space nationwide, and this is just a little close-up to show you what this looks like. We hand annotated in the annotation interface that's built into MapReader 62,000. When I say we, I mean I annotated 62,000 patches. The patches are the manually annotated patches are available on Hugging Face, as are the inferred data sets. And they've also been shared back with the National Library of Scotland as data sets that are derived from the map scans that are housed at the National Library of Scotland. I could talk for ages and ages and ages about this project, but I'm going to stop now. I'm happy to say more. You can check out the documentation for MapReader on our Read the Docs site, and the code is all up on GitHub. In the next year, we're going to be doing a bunch of training workshops for people from all kinds of disciplines. So if you're interested, I'm sure we'll be posting information on the website. So yeah, thank you very much. And if I could just show one quick thing. There's another, I was just really inspired by Barry's presentation, and I thought, oh, this is an audience that will really get excited about this. And because you showed the David Rumsey website.
I know where you're going.
Yeah. If MapReader is about understanding the visual information on historical maps, the other project that I've been working on, which is called Machines 3D Maps, has been about, and so in a collaboration that the project did, so that project is working with some computer vision scientists at the University of Minnesota, some librarians at the University of Southern California, other digital humanities scholars in the UK, and some software developer, Rainer Simon in Austria. So we worked with David and Luna, who kind of are the content managers for this, the front end and the back end for the collection. And we processed the half of the Rumsey collection that's georeferenced. It's about 57,000 maps. We processed that in the Map Curator tool that the Minnesota colleagues developed, which creates for every map sheet a GeoJSON file where every feature is the bounding box of a text with the transcription of the text and the confidence score, and et cetera, et cetera. And you can now, as of like 2 weeks ago, this is fully public. If you go to davidrumsey.com, you can search any text and see if it pops up. I like to search, for non-place names. You don't have to search place names. You can search for anything. And you can find all of the maps that have restaurants named on them. And so it really opens up what you can do with maps. If you want to find that variant of a place name for a place that is not going to be in the traditional metadata for a map, now you can search for that. Now, the quality of the results varies greatly. Anything that's going to be sort of pre-1750, the text transcription quality is going to be much lower, but it's surprisingly good. There is a bias to English as well. So we did run it through different language models, but the only thing you can search for here are the results that are based on text from, predicted from an English language model. So yeah, have a play around with it. There's a guide up here, Text on Maps Help Guide, that'll talk you through how the data was created, how, tips for searching, et cetera, et cetera. I just thought it's a fun maps thing. You guys might appreciate it. Okay, that's it. Yeah.
Any more questions for Katie? So I didn't introduce Katie. Katie McDonough from the Lancaster University Digital Humanities.
Yeah. Yes. sorry, any questions there? I forgot about questions.
The mic's over there.
Thank you.
What's next? I guess is it.
Well, yeah. Well, what's next for the text stuff is really figuring out how to make this technology available to not just other libraries, but also to researchers, and really to develop the methods for working with the data. So we're only just now doing our own kind of first papers using, we have the Rumsey data, we've processed some OS, we processed about 15,000 OS sheets and some other smaller collections. So that's happening.
Cool.
And then for MapReader, yeah, there's going to be a bunch of development still happening next year, mostly writing papers about rail space, but the pedagogical kind of interactive teaching, really seeing if historians and geographers and map librarians and people who are interested in thinking with maps will they really pick it up,
Yeah.
right? So this is kind of that moment of truth where you figure out, we found this really useful, and we're really excited to present a new way of working. Historians are notoriously very methodologically conservative, so, we'll see. But we're very open-minded. We like everyone. Anyone can use it.
Cool. No, that's brilliant. And it's all open source now.
It's all open. Yeah, we're really excited, really about building community in the next year. So the Read the Docs site has a lot. There's a contribution guide. We have a Slack workspace. There's a link. Joining Slack workspaces is always weird. So there's a little Google form, and if you fill out the form, we'll get a notification. We'll add you to the Slack workspace.
Yeah.
So we're really excited. If anyone wants to contribute to MapReader in any way or use it, we're get in touch.
Great.
Yeah.
Oh, that's
Thanks.
fantastic. Yeah. Yeah. No, there's plenty of time.
So thank you very much for a very, very interesting talk. I can actually put together your talk and Barry's to work out some sort of useful use cases,
Yeah.
So I think my question is, I kind of like, I know you're not coming from the textual input aspect of it. So your input is a map.
Right.
So,
Right.
which needs to be processed by a CV. And from what you said, there are models on Hugging Face that you are using right now. If I
We're putting our models on Hugging Face.
okay, you're
Yeah.
putting your models on Hugging Face. You're not fine tuning. Are you training your models from scratch? Are you fine tuning existing
So
models?
for this work, the knowledge computing team at Minnesota is creating models from scratch.
From
For MapReader, we're fine tuning models from
somewhere else. Okay, so what will be a typical use case? Because you're talking about other people, humanists, historians adopting. What do you think? How do you think you can sell it to them? Because what in my head, I'm thinking that since we can have big models like that, we can query them like we query anything, search for stuff, and ask specific questions about rail lines somewhere in the past, and then it comes out with some sort of explanation at the end instead of just the map. Is that possible? Are you thinking in that direction?
Oh, I'm not going to have that. Yeah. All right, that worked. Yeah. So
Okay.
here, well, if no, I want to see this. So if you go here, the thing that we've put a lot of effort into is this user guide.
Okay.
And so the user guide is basically very detailed instructions that helps you make decisions about, okay, are these appropriate maps to use in MapReader? How do I get them into the system based on what format they are? What choices am I making about labels so that I'm going to get some decent results? Or how do I learn to iterate through that? And then it walks you through how to fine tune models. So it's very, very, very detailed. It's the documentation is really written for people who have no idea what they're doing with CV, and there's a link to it. Introduction to Jupyter Notebooks, right? So it's meant to be very accessible. MapReader isn't for every map. It isn't for every collection, but we try to help. It's actually the input guidance is where we try to help make decisions about that. And then there's, in the worked examples here, the classification of 1-inch maps. This is just an end-to-end notebook with all the code. And so really all you need to do is change, your input file paths and the labels and things like this. So we've tried to make it as easy as possible for people to get started with this. And I will say, MapReader, it lends itself to a collection of heterogeneous maps that's large enough that it doesn't make sense for you to do this by hand. I don't recommend doing this for something less than like 500 maps. If you want really good quality data, just go do it by hand.
Thank you.
But I think that's the kind of thing. It's not going to work for something where you have like a hugely varied collection. It's just not gonna. It's just
thank you very much. I think you've answered my question.
I hope that helps.
Yeah, you did. Yeah.
So with that kind of 500 maps rule, that I guess reflects, the effort of getting started. How much time would, if I wanted to sit down this afternoon after this and bash up a model, how much time am I putting aside? Are we days, weeks, months? Aside from the annotation time, obviously. So the actual implementation.
Well, the annotation can go. You can do as many or as few as you want for starters, and then see. It's really just the inference, right? That will take time depending on the size of your collection. So for the second edition, 6-inch maps, doing the inference took about. And we weren't doing anything in parallel. We weren't doing anything fancy. We were just, and we're just using Azure VMs. So we're not using, big feed or anything like this. But that would take about a week for the inference for 16,000 sheets. But that's like 62 million patches. So that's like big. So when we do workshops, we have people annotate like 100 patches from about 6 maps, and then they do. It's all very, very dummy data, and the results are terrible. But you can go through the whole pipeline in that way and see how it works.
Cool.
And begin to understand.
And that's just giving you the patches that yes, this contains this feature, and then segmentation thing is then the next problem.
Segmentation. We don't do segmentation.
Yeah, exactly.
Right? Well, that's interesting. We really want to. We've been talking a lot with colleagues who want to use this to identify the part of the map that's relevant, and then go do a secondary task, that's in segmentation or object detection from just the relevant patches, because that's the thing with maps is they contain they're so big and all the information is very tiny. And there's so much blank space, especially on these old OS maps, that you don't want to try and process the whole. It's just too noisy. The results are too noisy. So that's another really good use case that we're hoping to work on.
Brilliant. That's great. Any more questions? Then I think it's lunchtime.
Yeah.
Yeah. Lovely. Thank you very much. So have a last round of applause.
Interesting diverse list of speakers. I'm sorry about technical problems earlier. We think we know we've